In this video, we're going to study springs. In fact, we're going to look at a very specific kind of spring, and one that obeys the Hooke's law of force. Let us consider a spring. Let us say that we have a spring, and let us say that this is the equilibrium length of the spring. Let us measure all distances from this position. Okay, so we'll just call it x equal to 0 actually instead of x0, and this will be this position will be where the spring originally ends. Now as we pull or push a spring, we'll measure its distance from this position. Okay, so let's exert a force on the spring and let's stretch it out. Let the force that we exert be capital F. Now when we do that, the spring gets stretched out a certain amount, and let the amount that gets stretched out be a certain, say, let's say it's x on this side. Now when this happens, what we understand is that the spring itself exerts a force, and that force that the spring exerts is to the left hand side. This force we call the spring force. So if the spring is pulled to the right, the spring exerts a force to the left, whereby it's trying to bring the spring back to its original length. Okay. On the other hand, if we were to pull the spring, or rather if we were to push the spring, it would get compressed, in which case the force that we exert, the outside force, would be some amount F again, and in this case what we know is that the spring would try to push back out, once again trying to bring the object to its equilibrium length. And again, this distance here, let's just call this the distance from here also equal to x. So what we know is that the spring force is simply opposite any change to the spring's length. If you pull the spring, the force is towards the equilibrium. If you push the spring, the force is once again towards the equilibrium. So it always tries to change it. Now the Hooke's law is a very specific kind of spring, and what we say is that the spring force F sub s is equal to negative k times x. Now let's understand this. In this expression, in this equation, so this is a Hooke's law. This is the Hooke's law. This where Fs is nothing but the spring force, and K is something called the spring constant. And you see the units of K are very simple. K would be some force over a distance, and so it ends up being equal to newtons per meter, and x itself is either the extension or the compression of the spring. So if you pull a spring, that's x. If you pull push the spring, that's x as well. Okay, and it's all measured from the equilibrium position. So all the x is simply measured from the equilibrium position. It is a change in the length of the spring. If you want to think of it, it is a change in length of the spring. Alright, so we understand these things. We understand what Fs is. Fs is the spring force, K is the spring constant, and it will differ for each spring. In fact, what we understand is that the larger the value of K, the tighter the spring, and the lower the value of K, the bouncier the spring. So K itself is a property of the spring. It will change from one spring to another, and X is the change in length of the spring. Now the negative sign here is something very, very important. It has a very specific meaning. Although in equations we will not use it because we'll already know the direction of the spring force, but it has a very specific meaning. And what it says is that this force is nothing but a restoring force. Okay, so the negative sign is what makes this force, the minus sign is what makes this force a restoring force. It takes this force, and what it tells us is that it is a restoring force, which basically means that this force wants to bring the spring back to its original configuration. It doesn't want to change, it wants to bring it back to its original configuration. It's a restoring force. And if you look at the two pictures here, okay, let's look at the second picture here where the spring is being compressed. Now when the spring is compressed, the X is positive, and when the X is positive, negative K times X ends up being a negative number, which tells us that the spring force is to the left. And if you look at the third picture, if you see that the X is negative, and in that picture what it tells us is that if X is negative, then negative K times X ends up being a positive value, and hence the direction of the spring force is to the right. So the negative sign essentially gives you the direction of the spring force, and also tells us that it is nothing but a restoring force. Alright, so what we know is we have the spring force, and the spring force that we're going to be interested in, which obeys Hooke's law, is going to be negative K times X. Okay, and once we know this, we can do a lot of other things. We're going to very soon find the potential energy of the spring. We're going to find the going to find what happens when the spring is compressed, what happens when the spring is stretched, and we can also look at what happens when you exert a certain amount of force by, say, adding a mass to the spring and hanging it up, and a lot of other things. So the key components that one must get out of this video is that we're studying springs. We have a spring. We start with a spring that is unstretched. Then what we realize is that when you pull the spring with some force F, the spring itself exerts a force in the opposite direction. When you compress the spring, once again the force due to the spring is in the direction opposite the change in its configuration. And we're studying a very specific kind of force which is called Hooke's law, or rather very specific kind of spring that obeys Hooke's law. Fs is the spring force, K is the spring constant which changes from one spring to another, X is the extension or the compression of the spring, or you can think of it as the change in the length of the spring, and the minus sign is a very specific thing, and what it does is it tells you that the force is restoring. And we looked at this example, these two pictures here, to realize that in this picture, in the first picture, when X is positive, in this one when X is positive, the Fs ends up being negative, and that gives us the direction of Fs is to the left. And in the third picture, when X is negative, it gives us minus K times a negative number, ends up being a positive value, and that gives us the correct direction for this force also. Now in calculations to follow, we will actually ignore the negative sign completely, and we'll use the direction of the spring force, and that's what we'll end up using in our equations. Okay, so just keep that in mind, that the negative sign of the spring force will be ignored. Alright, so that's it for this video.